Hello everyone, it's time to build the Z-axis. As you can see, there is an assortment of parts on my table, and trust me, I'm going to explain the purpose of every single one of these to you. Many of them are self-explanatory even if you are a little bit acquainted to 3D printing. However, there are certain design inspirations that went into these parts which you may not see in your everyday 3D printer. So, let's begin. First and foremost, I want to show you these. Many of you may have used these in your own DIY printer builds. These are essentially assembly guides. Rather than printing these, I got these cut on a CNC router, which is much faster and a whole lot easier. That being said, let me first explain the process to you. So we're going to begin with the bottom level assembly and then slowly work our way up to the top level assembly. And the first thing that goes into the bottom level assembly are these SK shaft holders and their appropriate assembly guide. Well, let's assemble these then. With those mounted, the next step is to assemble our motor mounts. The motor mounts themselves are made of 3 or 4 stainless steel because of its excellent thermal stability. NEMA 17 motors are known for melting plastic parts and even warping aluminium ones. So to be safe, I chose 3 or 4 SS. Speaking of motors, we need some for this build too. And luckily for us, our sponsor Fistech recently launched 48mm NEMA 17s which have enough torque to hold the weight of the stainless steel carriage and the 10mm bed on top. Link in the description below, check them out. The lead screws I will be using are TR8x2. I know I will be losing a lot of speed in the Z-axis, but the sheer weight of the carriage and the bed dictates their use. I will be coupling these to the motor with these spider couplings and to the carriage with these anti-wobble Oldham decouplers from Mello. This should allow me to have perfect prints in the vertical direction. Which now brings us to the stainless steel carriage. I had not anticipated how hard it would be to tap stainless steel. But after breaking a dozen taps and wasting a couple of parts, I was finally able to overcome all the trials and tribulations that strap threading could throw at me, and here we are. The interior was becoming far too grey and I wanted the machine to have a little bit of character. So I painted the bearing blocks in cherry red, which I think it gives a very beautiful pop. As I have already mentioned, the Ender 5 Plus frame is extremely space constrained and I had to do some clever design work in CAD to preserve every millimeter of printing area. For example, these mounting blocks for the SK shaft holders lower the stick out just enough for the tool head to have enough range of motion in the extreme sections of the build area. Okay, here is the top bearing retainer for lead screw. There is a bearing, an F608ZZ that's supposed to go in here, but obviously, as you can see, the bearing just won't go in. Now the easiest solution to this problem would be to get the part pre-made or maybe get a drill of that size and get that done. But the problem is the bearing's outer diameter is 16mm and I've already sized the outer dia to be 16.2mm, but I don't understand what's the problem. So here's a quick fix on how to resolve this issue. What you're going to do is take a small file, something like this, and roughly file the inner dia of this bearing. After you're done, try placing it in, but you see there is the bearing starting to go in, but it just won't go in easily. So what do you do in this case? You take that same file and cut notches into your part, little notches, something and cut small notches into your part at rough intervals. It doesn't matter that they are in some sort of deviation, just cut small grooves. Once that's done, what you do is place the bearing in the appropriate orientation and then give it a love tap. And here it's in. What actually happens is that once you cut those notches and push it in, the metal that's in those notches that's been cut away, the excess metal is smooshed, and this allows the bearing to sit in perfectly. The Z-axis is done, but there's always a but. Let me show you the but a little bit closer. Okay, the problem that we have encountered is an engineering oversight, not a mistake necessarily. The problem is I forgot that round bearings are also prone to rotating, and as you can see, it's rotating. Now the idea that in my head was that one axis would be limited by the bearing itself and the other axis would be limited by the lead screw itself. But I failed to encounter the fact that I was going to use Oldham decouplers, which in their name say that they would decouple the axis and the roll axis would have its free range of motion. Now, how do we solve this? There are two solutions to this. The easiest solution would be I can simply remove the Oldham decoupler and directly mount the lead screw nut over here. But the issue would be that the Z wobble would ruin the print quality. The other solution, which is a bit difficult, would be for me to go ahead and add another bearing over here. This would restrict the motion in this rolling axis and in turn resolve the issue. So join me next time where I solve this issue and I add a bottom enclosure plate to seal the bottom